Welcome everybody to our first reproducibility meeting from the European Association for Research in Learning and Instruction. And it's a great pleasure as first speaker discussing the issues with current research and why we should engage with maybe open science practices is Tatiana Shubina from the University of Oulu. And thank you, Tatiana, for being our first speaker to encourage the debate around most published research findings are false. So very interested to hear more about that, and thank you. Over to you.
Thank you very much. I'm very happy to be here today and very happy to talk about this quite sad topic, though, or at least, well, kind of bothering for me. So as you mentioned, we are going to discuss the current issues with the science, and if I have to summarize it quickly, the problem is that the most published research findings are false, and we are going to check today why. Well, first we will check the factors that contribute and that increase the probability of false findings. I introduce it as the post-study probability that a finding is true, or PPV. And I took this term from Ioannidis' paper. Then we will have a quick look on how bad is the situation actually. And as I want to finish on something positive, finally, we will discuss solutions to some possible solutions to this situation. I imagine this talk to be more, how to say, continuous discussion like talk. So I will stop every now and then and maybe ask you for some reflections or your ideas and points of view. And I really want to be more as a part of the talk rather than a leader. And what else? Well, I think we can start for now. So as I said, there is some post-study probability that our findings are true, and this depends on study power, bias, and prior probability of the findings to be true. Let's start with the study power. I apologize if I go sometimes too detailed, but I added some notes, as I mentioned, for students, for example, for the future. So the statistical power of a study represents the probability that a study finds a true relationship or an actual effect, or in other words, to correctly, it's the probability to correctly reject the null hypothesis. And quick note, the null hypothesis is that there is no relationship or effect. When the hypothesis one is that there is a relationship and effect. And statistical power can be denoted as 1 minus beta, where beta, a quick reminder, is the probability of making type 2 error. Type 2 error, or otherwise false negative error, is when we fail to reject the null hypothesis, when it's actually false. This type of error is less frequent, but still shouldn't be underlooked. Then statistical power can range from 0 to 1. And the higher is statistical power, the lower is the probability of making a second type of error or false negative. Okay. And statistical power of a study depends on these factors: the sample size of the study, the magnitude of the effect, and the statistical significance, or alpha. Alpha instead is the probability of making the first type error, or false positive error. So when we reject the null hypothesis, when it is actually true. And there are a couple of points that I highlighted from the papers I read about sample size. Well, in short, we can say that smaller the sample size, we have the smallest probability of the findings to be true. And what is interesting, or at least it was interesting for me, is also that the general level of the size of the study, it matters for the probability. So it's not only concerns your study as a single, but what happens generally in scientific field. And the same is for the magnitude of the effect. So when the effect sizes are smaller, and especially in a scientific field, less likely the research findings are to be true. And here already I wanted to stop for maybe a couple of minutes and to ask you about your opinion. How much do you think are these two factors, sample size and the magnitude of the effect, how much they represent risks for our scientific field specifically, so education? What do you think? Are they really relevant for us?
Well, maybe from my point of view, I'm in the field of like special education. It's quite hard if we look at like if we want to get a sample of students with mathematical learning difficulties. It's quite it might be quite difficult to get a large enough sample size. So that's quite hard.
Yes, Joe, please.
Yeah, I think that's a great question you're asking, because I think it links to the question whether these are issues just for quantitative studies where, you know, magnitude of the effect matters, or whether this also then relates to qualitative studies. And I think it goes back to the issue that the reason why these are problems for quantitative studies is because the research doesn't replicate, right? And you might talk about that later on. And I think that's the main problem, is that many studies don't replicate. And that's the same also for qualitative studies. You know, if there are particular if there are particular issues not addressed in terms of methodology. So I think, you know, you can have qualitative studies with small sample sizes, which is what you usually do in qualitative studies because you're interested in the individual, but that doesn't necessarily mean that these studies are, you know, free from replication biases, if that makes sense. So I think it affects everybody, whether it's in the field of quantitative or qualitative or education or psychology. But it's started. I think it's the magnitude of the effect is of course specifically a problem for quantitative studies. Anyway, I'll let other people speak now.
Thank you. Anyone else, or we can continue? Okay, I will continue then. Oh my God, I can't see my presentation. So. Statistical significance. Yeah, there is a huge discussion about statistical significance, and I'm not going into it that much, at least yet. Maybe we have time for that in the end. So I highlighted some main points here. I think the main issues. I think the first issue is that we often we trust too much the formal statistical significance, or 0.05 level, and we kind of don't consider other factors that might influence and actually increase the possibility of the false positive error. And I think another Another issue there is also that we sometimes trying to chase it. So we have this number and we, again, don't consider different factors. We want just achieve it. Once we achieve it, we are happy and that's it. So I think the short conclusion here is that we should be more careful and more conscious when we make conclusions based on statistical significance. And we have to keep in mind also that there are some post decisions we take that might lead to statistical significance when it shouldn't be. And from here, we go into bias. So the second factor is bias. What are bias is a combination of various design, data analysis, decisions that may influence our findings and may lead us to false steps. And again, here a quick question. I wanted to ask you to reflect on decisions you think that might influence the results, something that we commonly do before or after the study. Or maybe something that you are especially careful about, like for you when you do your research. Maybe I can start. Oh, sorry. Yes.
Yeah, I just wanted to light it a little bit up and just wanted to say, well, it always depends on the reviewers. If they take another approach, I guess we all have experienced before that we suddenly change our direction in our mind and just write what might be helpful to bring this paper back or bring this paper to publication. So it's more part of the review process, what I suggest.
I think, Sebastian, that's a good observation, but I think that's at a later stages. I think, you know, there are biases that go throughout the project that you know, any project that people need to be aware of. So, for example, I don't know within your field or within your team that you work in terms of, you think about who are your participants, are there any biases there? So I know, you know, even though I work in London, that the populations I work with are still mainly middle-class white backgrounds, whereas actually that's not representative of the populations in London. And that again creates certain biases, or how often we do, and maybe it's not so much the case for people on this call, but in the past, a lot of psychology and education, I mean, especially psychology research, was done with undergraduate psychology students, right? Or in education, it was done in particular schools, but not in other schools because, you know, we didn't have access to those schools. So those are the kind of biases. But I think, you know, you might, you know, there are some interesting things around, you know, what biases exist, and also in reviewers, when we look at what is considered good work in terms of biases, and which biases are we conscious of in terms of, you know, we look at them specifically in a paper, or we look at them specifically when we look at research, and which biases are maybe harder to spot or to address.
Yeah, I listed some ideas from the papers. And also Simmons, he calls these biases researchers' degrees of freedom, the kind of decisions we take that may influence, and they concern outliers, how much data we are collecting and when, and yeah, surely some other things we just discussed. And specifically, Simmons lists some concrete actions that might increase the possibility of false positive error. So, for example, testing and choosing among more than 2 dependent variables, testing and choosing among more than 1 covariate. Then choosing a sample size. I would add from me here, I think that what is meant here is that we don't have any like concrete foundation on how we choose it. What I found interesting also, conflict of interest and gains or pro significant results. So this can interfere with the final result. And here are some conclusions I wanted to show you and to discuss with you. So we have some, in addition to all previous factors, we have some prejudice, and there could be conflict of interest, of course. And I wanted to say a couple of words about prejudice. I think it's interesting that, well, often when we talk about prejudice or conflict of interest, we think of immediate things such as when somebody pays for your research and then you get the positive findings. Okay, this is pretty straightforward. But I think what can often happen is that people are kind of, they fell in love with some theories and they just want to, they only see the findings that support these theories. And I think this is really a big risk, a frequent risk, because, and not done, of course, from like, it's done unintentionally, of course, but still something to think about. And also what I highlighted was the university agreed terms, universally, agreed terms. I think that human sciences suffer a lot from this. So we have, to my opinion, we have a lot of concepts that overlap or completely or partially, or they have several definitions. And when we are not precise with what we are measuring, it's actually, I think, a problem. A big problem also is that when we call differently the same thing, we might not see each other results, for example. But I don't want to talk too much on that. Maybe anyone wants to add on these points anything. Yeah, please, maybe you just jump in because I'm not sure I'm seeing everyone. So
Sure.
Go ahead. Yeah.
Sure, I'll just, yeah. I was, I had the same thought when I read the papers, like that, like some may just fall in love in their theory, and everyone wants to find something significant and do a significant dissertation and everything. And then I was thinking, like, conducting statistical analysis, for example, like structural equation modeling, because when you run those models, you like try several, like maybe hundreds of different models with different mediators, estimators, and everything, and it's not completely like straightforward what you should theoretically or statistically what you should choose. So like if you think of what directs into the fact that what model you will choose for the article, and if you think of like there was discussion on the in the paper that you should report like every single step of your statistical analysis, but if you run like hundreds of models, you just simply cannot report all of them. So how to like choose what to report, and those were just things that I this topic.
Yeah, thank you. Mariana, do you want to add something?
Yeah, I agree with you when you said that the way the characteristics are measured, they may yield different results. And I see this a lot in psychology, like the way the scales you use to measure like depression or even other things, even some neurodevelopmental disorders, they can change the results of the studies a lot when you try to like summarize the results to get the best evidence right for your practice. It's really hard to find. That's it.
Yeah.
I just want to add on, I think I've made, or I want to share one experience I've made during my PhD. I think the more researchers think of their theories or methods they apply in terms of something religious, it's the holy thing I'm doing my research on, the more it is likely that they test for several independent variables, all the issues that are being discussed in the two texts we've read for today. And I also wanted to add on Terry's comment. I hope I pronounced her name correctly. I was just wondering, when you reflected on structural equation modeling, a model class I really love, but also I totally agree with your assumptions. I was kind of wondering how much, I mean, there are two sides of the coin, right? So there are theories and we can test these theories, but also the quality of the theory and the hypothesis we can test in accordance are important for this issue, because the text, well, I would say discussed more the statistical part of our research journey, but also I would say how we can improve theories to make them more testable is also an important issue in this debate.
Yeah, and maybe it's something, how to say, simple and redundant, but I was always thinking it would be really cool if somebody could keep track, like kind of glossary on the concepts, and where you could quickly, you know, check how this phenomena could be called in other even in other fields, but even within field often. And yeah, find the results you're interested in then. Because then when you use keywords and you use a different term, sometimes you just don't see a huge part of something that is relevant to what you're looking for. All right. Sorry, I forgot to say that because it appears in the later table, bias were represented under U letter in Ioannidis' paper. So please keep this in mind. Anyway, let's continue with the final factor, that is prior probability of a study to be true. And that was a bit eye-opening to me. Personally, I've never thought about it. Like, I've never thought that this can influence really the probability of our results to be true. And I can't explain it very well, but there are like calculations done in the paper showing this, and specifically this was interesting. I think I have to reread this to understand it better. This ratio about true and no relationships in the field that influence the final probability of our results, and also number of studies on the same question. It was curious to hear. I mean, I had some intuition of that, but still it was curious to hear that the hotter is a scientific topic, or then there are more teams involved, the worse, like that, or let's say differently, the less likely the research findings are to be true. And one of the examples was because of competing, maybe time pressure, I was thinking also, or negative results are not attractive. And this point made me think a lot about COVID studies and the quantity of COVID papers going out. Well, anyone wants to add something on this, or I can continue? Okay, all right, then let's continue and let's check how bad is actually the situation. We will not focus on it too much, but just a little bit. So the first table, I just copied it from the paper of Ioannidis, where he summarizes the post-study probability of results to be true. And I will remind you quickly the columns. So the first column is the power of a study. One of the factors we discussed, then U were bias. R, big R, is the ratio between true relationships, no relationships in the field. Then we have different combinations of numbers, what can happen. And I was happy he added the practical examples. It was easier for me to follow. And then the last column is the final probability. And I was reflecting on research that I most often come across where it would fall in this table. And well, I think we are somewhere we're somewhere in the end between 0.2 to the last number, and this is pretty sad to me. So I wanted to hear your opinions on this table. What I wanted to ask. Yeah, so where do you think the research you deal with lay according to this table? Because I guess we don't use randomized controlled trials, at least.
I was saying the same, that at least I have not been a part of like conducting RCTs in the field and don't know much about conducting. But I think that during the COVID time, systematic reviews and meta-analyses have been like increasing. So I think those could be in the upper end of this table more, but there, of course, it depends on the primary articles that are included. Yeah.
Okay, maybe we could check quickly this another table. Here from the second paper, Siemens paper. So what he does, he focuses first of all on false positive result only. So it's more focused compared to previous paper. But again, he calculates the likelihood of obtaining false positive result when we have different factors. And it's based on significance level. And well, I think the conclusion from here is pretty the same, that the chances of getting false positive results are quite high. Yeah, however, quite high, I would say. Does anyone wants to add anything on this? Okay, maybe we can continue. So let's go into the positive part of the presentation. There are some solutions, some suggestions, and here I wanted to discuss with you more to kind of evaluate these suggestions. So basically my thoughts were pretty the same. So how do you think they are feasible, not feasible? Is it like a good idea for some reason or not? And things like that. I divided these solutions into 3 categories according to Siemens, but I added ideas from both papers, and there are some ideas what authors could do to avoid risks of errors. Yeah, let's check those. The first one is about data collection. We briefly saw this in bias. So is the advice to decide the rule for terminating data collection before data collection begins. And of course, report what's going on with data collection. I would reformulate the second one as collecting enough observations for what you're doing, to list all variables collected in a study, report experimental conditions, including failed manipulations. And here we had already some thoughts, like whether it's feasible, because as Terhi said, sometimes you try out many things. How can you include it in the article? This is a good question. So if observations are eliminated, report what the statistical results are if these observations were included, and report statistical results of the analysis without the covariate. Okay, so what do you think? Do you want to add anything on this? I think some things look quite obvious, but however, I think not always followed or by everyone, I would say.
Yeah, and I would also add that, like, from a reader's perspective, that it would be nice if more researchers would report like more clearly the outcome measures, because I think that quite many do the way that they just say that we use these items and these are from this and this article, and then you go like miles away from the original paper to find the items, and still maybe you cannot even find those. So it's like really hard to deduce what have they measured. Mm-hmm. And also I think that like it's important for the reader to understand the procedure. If the measures were conducted in the preschools or the schools, or maybe the participants came to the university, and whether they were tested individually or some sort, whatever is relevant for determining whether there's bias or whether the results can be affected by other factors than those that are reported. But I know that there's also word limitations and everything in the journals, but it would be nice if there would be more openness in these things too.
Yeah, well, what came to my mind as an idea to this, maybe some kind of protocols of a study must be encouraged, and maybe in future we could publish those somewhere. So like you don't need to include it actually in the article, but there is some link that is easy accessible, and you can know more details if you want to. Yeah, okay, this is not the full list. Then we have also these suggestions. Well, we talked a little bit about larger style studies, but again, not always possible. This is not always possible. This is a problem, especially if you are dealing with some very specific groups of people, or you have limited budget, for example, and especially children. It's not easy to get a huge sample often because of policies, for example. Anyway, yeah, it's not that easy to do. Well, the second one, to pay attention to the totality of evidence and not the statistical significant findings of any single team. Yeah, I think this is a good point and quite easy to follow. Then diminish bias through enhanced research standards and curtail prejudice. Yeah, can't disagree here, at least, yeah, to my opinion, this is quite straightforward. Use the principles of developing and adhering to a protocol borrowed from the randomized controlled trials. And 1 second, I remind, so randomized random assignment control, when people have control group and ideally well blinded, it's like a golden standard of science, but often in education, at least, we have very different settings, and often it's, for example, school setting and not lab. Well, we can discuss this later. Another suggestion is do not chase statistical significance. I can't disagree. Before doing a study, consider what are the chances that the relationship is true, if we are studying a relationship, and consider experiences from biases detected in other neighboring fields. Well, I think the last point is easy to say, but I think in practice, we often are so busy that we don't have to check properly what's going on in other fields or even neighboring fields. It would be nice to be more multidisciplinary, but I don't think. I'm really sorry I dropped out. Let me open them, share the screen again. Okay. Sorry, I didn't hear if anyone had some thoughts on this part. If not, maybe I can continue. Okay, the second one is some suggestions for reviewers. So reviewers should ensure that authors follow the requirements, prioritizing transparency over tidiness. I think this is a nice point. Transparency, it's a very important thing. And Simon suggests that reviewers should be more tolerant of imperfections in results. And I think this is also a great point. And I think having negative results should become more and more okay in researchers' mentality generally. So we don't hide our kind of mistakes or maybe unsuccessful studies if they make sense, if they still make sense, and if they add still something. So next one is reviewers should require authors to demonstrate that their results don't hinge on arbitrary analytic decisions, or if like there are some arbitrary analytic decisions, then it should be discussed what could happen with an alternative decision. Well, the last one about replication, I don't know what in practice should be the case that you ask for a replication. I think this is quite huge request and not often possible to do, especially, for example, if we are talking about a paper of a PhD student. Sometimes it's not even your like project and you can't do much about what you can do, what if you can replicate or not. But again, please let me know if you have any thoughts on this, if you have anything to add. Okay, then I will continue with the last and I think the most interesting part about non-solutions. And here I'm curious to hear if you think that these non-solutions as defined by Siemens, they are really non-solutions, or maybe they are good solutions. Let's reflect a little bit on this. We still have some time. So the first one is alpha levels. As I mentioned, big discussion about alpha. It would be really nice to have a comprehensive table where you could, have some input factors and then have your specific alpha level for your situation. But right now it's not clear how you can adjust alphas based on the degrees of freedom of different combinations of degrees of freedom. Then there is Bayesian statistics, and as Siemens mentions, the problem here is that it adds one more possibility for decision. So you can take one approach or another, and so it in the end increases researchers' degrees of freedom. Then conceptual replications, so replications of the findings in different populations, for example, or settings. The problem there is that, however, these replications don't bind researchers to use the same analytical methods, and so can we really compare the studies then? This is a question. And the last one, posting materials and data. The problem here is that it raises costs on readers and reviewers. But in my opinion, I think it's still a solution. I don't see it as a non-solution to me, especially with current technological possibilities. I don't think it's a huge issue, and maybe it's even a good solution, as I mentioned, for protocols and other things. I think we just need for more transparency, and we just need to open up a bit more on what we are doing and how we are doing that. And if you can't include every single detail in your article because of word limit, I think it's nice if you could post this information somewhere else, and those who are interested could assess that. Please let me know if you see any problem with this, or if you want to discuss any other points of these four. And from here, I basically stopped my presentation, so that was kind of the last important slide. So we can also continue with some open discussion. Please, Mariana.
I also believe that posting the materials and data would be a good solution, because people don't have to look through them, but it's a possibility. Having this possibility can be a good thing, especially if you are in a research group or in a team that is researching something similar. So you could go deeper in the data. Maybe not everyone are going to look into this, but it would be a great addition, I believe. And you already have the data, right? He organized it for you to use. So maybe you could just like share in the paper with a link or something.
Yeah, I think it raises also trust. Even if you don't like double check, then if I know that I could do this, then I have more trust in the whole work. The same as references, as when we are referencing. When I say something and I put no reference, that it can be just from my mind, there is no basis. But if I put reference, then interested people go and can check the initial source. I think with the data and the empirical part, it can become also similar to what we do in theoretical one. Of course, there are some privacy matters, and you have to anonymize well your data, for example, and it might be there are some restrictions for some reasons, again, policies, and of course, but as a general rule, I think it would be nice. Anyone else wants to say something?
Hi. I read something about replications recently, or read in a lot, and the distinction between these conceptual and exact replications, I think we can drop. So I think replications are still important, and it's on a continuum between exact and conceptual. You can have changes in the sample, changes in the country where you assess the study, or in the measurements, or in the statistics. So one of the suggestions in one of the papers was that you make like a meta-analysis, and you do select all the different steps that you can change, like in the analytical decisions, and show how the effect is then. And then you change the analytical decision and show the next step. It's similar like to these forest plots of a meta-analysis. So yeah, I think replications, even if they're more conceptual, they're still important.
Yeah. All right. I will go to the main page. Okay, I think it's last chance to someone to speak out. Otherwise, I think we can also start closing the session. It's very close to the end time. And well, maybe I try to conclude somehow from all this. Well, I think there are challenges. Of course, there are a lot of challenges when you are doing research. And one of the challenges is what we just discussed, that your results can be false, and there are high possibilities of that. But I think what generally helps is to be open-minded. And when you are open-minded and you are critical to what you are doing, and maybe try not to get offended of other people who make comments on what you do, I think that you are in a safer position. I think the most risky combination is when you believe too much in something and you get a bit blind and you don't consider factors or suggestions and things like that, and you just want to do your thing. I think this can be in the end the misleading path. But if we keep open-minded and we try to aim for transparency in all ways possible, I think we increase our chances to do something significant and to bring real scientific results to the world. So I thank everyone who came. To me, it was nice to talk with you on this topic, and I hope that we will have later on other inspiring discussions.